Hello there. Um, Before I get started, please make sure that you subscribe to my channel. I'm trying to hit 500. I'm still short, like 13 short right now. So let's do it. The more subscribers I get, the more videos I can do. And I want to help everybody succeed in stats. That's my goal. And I do this stuff, but having the subscriptions helps me out a lot too. So get me over 500 for starts, and we'll shoot for 750, 1,000 after that. So let's get started. Okay, so and it doesn't cost you anything to subscribe. Just in case you're wondering about that, it doesn't cost you a single thing. I subscribe to all people that, you know, whose videos I watch all the time. I want to make sure they get, the support that they can get. So if I'm helping you out, please help me out by subscribing. You see the button on the bottom right-hand corner to subscribe, please do so. All right, so let's go with this new Wegmans problem. So I shop at Wegmans a lot. It's my favorite grocery store. I talk to the cashiers a lot when I'm there. I ask them questions. And I did this problem before where I asked the cashier about these items per minute, the IPMs. And she gave me a value that was really light. It was like 7 or something like that. So I thought, okay, it sounds like it's good. But that's not the most accurate average. So that was that average items per minute that she gave me. But I spoke to a lot of other people since then. Like today, I was shopping and I asked this young woman who was working at the register about her IPM, and I was looking at it. It was showing up on her screen and was like 19.84. Wow, that's like 19.84 items per minute, which is good. And it seems like the stores want you to be around 20 IPM. So she's obviously meeting her mark. And she pointed out where I could find the average, because I need to know the average in order to calculate the probability of getting a 20. So on this board, they had the average IPM, which was for that store, 12.75. So I wrote that down here. And my goal, I told her about this problem. I called the Wegmans problem. And I told her I can calculate the probability of getting 20. Her value was actually 19.84, which I just round up to 20. So I said, okay, let's calculate the probability of somebody processing 20 items per minute if the average store average is 12.75 per minute. So this is the probability of a count. An account is a type of discrete variable. And in this case, it follows a Poisson process. So we're counting how many successes there are, but we also have some kind of like some constraints. In this case, it's minutes, right? So we get the average items per minute. And when we have that kind of constraint, we use a Poisson. If it was just like how many successes there are, we'd use a binomial. But in this case, when there's some kind of a constraint, like the minute in this case, we would use the Poisson. And this is the Poisson probability mass function. We have lambda. Lambda is our rate parameter, lambda raised to our x, and x is whatever we're looking for. In this case, it's 20, so x would be 20. E to the negative lambda divided by x factorial. Of course, we get these really large numbers here. So you'll see that, we have basically this really, really large number where we move our decimal place 22 spaces. But, we get this because we're dealing with these pretty big numbers anyway, right? So in this case, we have lambda to the 20. So we've got 12.75 raised to the 20th power, e to the negative 12.75 divided by 20 factorial. After, I plug everything in, I got 0.0158, or basically, 1.6. There's a 1.6% chance that somebody would be able to process 20 items per minute given this lambda here. So she did pretty good. I was thinking, well, for alpha 0.05, that's certainly less than an alpha. So we'd be considered significant if we were using that. Again, we're just dealing with one person here. So that's a nice result. I had gone to a store in New Jersey, and in this store, they said, their average IPM was 16. Now, I saw a listing of their IPMs per employee, but they didn't have an average written. Like the store that I went to in Pennsylvania had the average written down. So I'll take the word of the employees. That's pretty big, right? So what would happen? And what's the probability of getting a 20 given your lambda is 16 items per minute? So in this case, again, we write our equation lambda to the x, e to the negative lambda over x factorial. If you don't know what factorial is, that's n times n minus 1 times n minus 2 times n minus 3 until you get to 0. Eventually you get to 0, and 0 factorial is 1. So this is 20 times 19 times 18, etc. And e here is Euler's number, e to the negative 16. So we had 16 raised to the 20, e to the negative 16, and 20 factorial. And then again, these are some really large numbers here, right? Makes sense. And a small number there. So we ended up getting 0.0559. So there's essentially a 6% chance of processing 20 items per minute in that Jersey store. Well, it's still pretty good. I mean, that's higher than the 1.6% we had in Pennsylvania. So you're a little less special here if you get 20, but still quite special. I mean, the probability of not processing 20 items per minute would be something like 94%, right? So that's still pretty good, right? So that's the Wegmans problem in a nutshell, redone with new data. All right, hope you enjoyed this. Remember, subscribe and like this video. Thank you. Bye.